Spacey. Spacey is an open source software Python library used in advanced natural language processing and machine learning. It is used to build information extraction models, natural language understanding systems, and to pre-process text for deep learning. It supports deep learning workflows in convolution neural networks, in parts of speech tagging, dependency parsing, and named entity recognition. Spacey is written in Python language. Now, if you're wondering if there's a typo that I've made here, giving a C instead of P in Python, it is in fact Python itself. Python is basically C extension of Python designed to give C-like performance to the Python program. Hence, it is a quite fast library. Spacey provides a concise API to access its methods and properties, governed by trained machine and deep learning models. Installation. Spacey, its data, and its models can be easily installed using Python package index and setup tools. Using the following command, we can install Spacey in our machine. Sudo pip install Spacey. In case if you are using Python 3, you can replace pip command with pip3 and install Spacey. To download all the data and models, you can use the command python setup.py install. This command here can be used to download all the data and models and run the following command. Run the command, that is this command right here, after the installation. And then to download all the required libraries, you can use python -m spacey.en.download all, which is right here, which will download all the necessary libraries and packages to run Spacey. You are now all set up to explore and use Spacey. Spacey pipeline and properties. Implementation of Spacey and access to different properties is initiated by creating pipelines. A pipeline is created by loading the models. There are different types of models provided in the package, which contains the information about language, such as vocabularies, trained vectors, syntaxes, and entities. We will load the default model, which is English Core Web. We'll import Spacey and create a variable NLP where we load the English package. The object NLP is used to create documents, access linguistic annotations, and different NLP properties. Let us create a document by loading a text data in our pipeline. We give the Unicode and open the file and decode the UTF-8 and give it into the document. The document is now part of spacey.english models class and is associated with a number of properties. The properties of a document or tokens can be listed using the following command, that is dir document. Dir is short for directory. This outputs a wide range of document properties such as tokens, reference index, parts of speech tags, entities, vectors, sentiment, vocabulary, and so on. Let us explore some of these properties. Tokenization. Tokenization is something we have done before, where we tokenize a sentence into its respective tokens, discarding the unnecessary spaces and so on. Every specie document is tokenized into sentences and further into tokens, which can be accessed by iterating the documents. The first token of the document is taken as document of 0, which prints out the word nice. We have assumed that a certain document has been given as the input to the machine, and hence nice is the first word in that document. The last token of the document can be given as document length, length of the document minus 5. The number 5 is given because there are the multiple spaces after the last word is discarded, and all punctuation marks in the end are also discarded. Then we list the sentences of our document by using the list keyword. And when we list the document sentences, notice how the output is not given as a paragraph, but indeed given as sentences. Here we can see nice place, better than some reviews give it credit for, is one sentence. Hence, it is separated by the next sentence, that is, overall, the rooms were a bit small but nice. And so on, every sentence is listed out and separated by a comma. Parts of speech tagging. Parts of speech tags are the properties of the word that are defined by the usage of the words in the grammatically correct sense. These tags can be used as the text features in information filtering, statistical models, and rule-based parsing. Let us check all the parts of speech tags of our document. We get all the tags by giving the word dot parts of speech for the words belonging in the document. You see that the when the words are mapped to the parts of speech, the parts of speech can be verb, space, adjective, adverb, conjunction, pronoun, punctuation, and so on. All the tags of the first sentence of a document are considered now. Where we run a for loop for the first sentence in our document and print the word tags. Where we have nice as an adjective, place as a noun, and so on. Entity detection. Spacey consists of a fast entity recognition model which is capable of identifying entity phrases from the document. Entities can be of different types, such as person, location, organization, dates, numerals, and so on. These entities can be accessed through the .ents property. Let us find out all the types of named entities from, from the present content in our document. We set the labels to the words labels in the document .ents, that is, in the entities of the document. For label in labels, that is, we are running a for loop for all the labels. We clean up the entity, and if it's present, we give the label as entity label, and then we list out the entities and print the labels and entities. Dependency parsing. One of the most powerful features of Stacy is the extremely fast and accurate syntactic dependency parser, which can be accessed via the lightweight API. The parser can also be used for sentence boundary detection and phrase chunking. The relations can be accessed by the properties such as .children, .root, .ancestor, etc. If we remember correctly, our sentences are converted into the form of parse trees. Hence, in dependency parsing, children would be the child nodes of a particular node. Then we have the root node and the ancestors, which are the parent nodes of the current node. To perform dependency parsing, we extract all the review sentences that contain the term hotel. We convert all the words into lowercase and then we extract the sentences that contain the term hotel. We create a dependency tree. That is, we create a sentence where hotel for if hotel is present in that sentence and print that list of strings. And when we list out the sentences, we have a cab from the airport to the hotel and all these words relating to the word hotel.